All right, so welcome everybody to our pepper coding masterclass. We have here Kantwon Rogers, and we have here Amy George, our K-12 representative from Robot Lab, and Michael Henrik, our higher education representative from Robot Lab. Thank you so much for joining and get ready to learn a lot about pepper and everything that Kantwon has been doing with an amazing experience with the robot. So Amy, let's just get started.
Okay.
Yep.
We're going to get our screen going here. Let's make sure everyone can see our screen.
Perfect. Yeah, we can see it. Go ahead, guys. Thank you.
Awesome. So thanks for joining, everybody. Good morning, good afternoon, good evening, wherever you're based from. Today we're doing a webinar all about Pepper. We call it Pepper's Playground just because Pepper's essentially like a sandbox. So you can play with her, you can program, you can have her set up for so many different use cases. So just because something hasn't been done with Pepper yet doesn't mean it can't be done. And that's the awesome thing about fully programmable robots is you can, whatever your creativity goes, that's what you can do with Pepper. So our agenda for today is talk about Pepper, how she is in K through 12, higher ed, and then have Kantwon take over from there and talk about his awesome research he's been doing with Pepper. Before we get into Pepper, we're just going to talk about us here at Robot Lab and how we even got involved with Pepper in the first place. So we were established in 2011. Now we're a leading integrator in robotic solutions. That means we don't manufacture any robots, but what we do is we handpick the best robots from every single category, from education to business applications in hospitality, restaurants, assisted living facilities, cleaning, and because of that, we've been growing pretty quickly over the last couple of years with offices popping up in Texas and the most recent one in Colombia, where Maria is based from today. Overall, worldwide, we've got over 32,000 customers. Over 20,000 of those are U.S. domestically. So we're present in almost every school here in the U.S. And our offerings don't just stop with the robots. We offer support and repair services. We're actually the only service center for Pepper and Now across the board. So anything that has to do with support, we're there. We have dedicated teams and dedicated repair center for that. And we take everything from after the sale, any technical support, deployments, and things like that. And yeah, our goal is to revolutionize lives and industries through tech, because that's where everything's going with AI and robotics, and we feel that can only impact society in a positive way. Our team here, Maria briefly touched on it, but Maria is our marketing manager. Amy is our K through 12 account manager. I'm the higher ed. And we also have Kantwon. So Kantwon is a computer science doctorate student. He's an instructor also at Georgia Tech. He's got a computer engineering bachelor, electrical computer engineering master's, and master's in computer interaction. Research is in AI, robotics, and he looks into the ways that pro-social deception has on HRI, on the genders, and in interesting ways. Like, is it good if a robot can actually lie to you as long as it positively affects you? So he'll be able to touch on those topics when he talks about his research with Pepper. And to briefly talk about applications, cool use cases in K through 12. Pepper has facial recognitions software, so she can actually recognize you by your face and give you certain things, certain feedback based off what she remembers about you, and then overall STEM education. So since she's fully programmable, there's all sorts of hands-on teaching and curriculum that can be built around Pepper and have a whole course done, and that's interactive and gets the kids excited about working with robotics and ultimately working on programming and coding. In higher ed, it's the same thing, but obviously it's a bit more advanced, so a lot of research, a lot of development, building on top of previous research that has already been done, collaboration between lots of different universities and research institutes is where Pepper is today, where her use cases with her ongoing AI developments. So that way we can understand how that human-robot interaction works, what are the best use cases, and how to best integrate robotics into our world. So, and from there, we'll let it hand over to Kantwon.
The start of the show, and obviously Pepper. Thank you so much for joining us, Kantwon. The mic is all yours.
Awesome. So hopefully you can all hear me. Let me go ahead and share my screen.
Perfect.
Okay. Let's see. Can everyone see my screen?
Yes, we can. Perfect.
Awesome. Fantastic. Well, hello there, everyone. I'm very happy and excited to be here to kind of tell you all about myself and the research that I'm doing and some cool stuff that I've done with Pepper as well. So they already kind of introduced me, but just as like a reiteration, so my name's Kantwon, and for the last like 13 years, I have been a professional Georgia Tech student. For me, I always felt like if I was a student, I was never like a real adult, so I'm just going to stay in school forever, so I never actually have to grow up. But I have taken some time where I've like interned at different tech companies, including Intel, Google, and Amazon, doing a variety of kind of artificial intelligence projects and robotics projects as well. But I will say, in full transparency, I didn't like any of it. I realized that working at a company is not really for me, specifically because, like they had said as well, for the last 7 years, I've been an instructor for a huge intro to computing programming class here at Georgia Tech for engineers. Like 1,000 students take it every single semester, and I get to be one of the teachers for it. And it's been so life-changing. And so my own career paths are really to go down academia and be a professor and all that stuff. So I love the idea of teaching and education, and I think that's where I was meant to be. But actually, I have a question for all of you. Like, I just explained all this stuff about myself, but how do you know it's true? Like, I could just be lying to you about all this stuff. I could have lied to the robot lab people. I could have never gone to Georgia Tech. I could have never interned at these places. I could just lie. And it's interesting because when you think about it, humans lie about everything. Like, we lie about small things. We lie about big things. We just lie all the time. And all the time, it's not necessarily for like bad reasons. We can lie to kind of help people as well. But since we lie in every single context, this is interesting when we start thinking about how we're designing robots and technology, and we want them to learn from humans and interact in the same way humans do. And so I'm sure everyone and their mom and grandma at this point in time has heard of ChatGPT. And so the company that makes ChatGPT, OpenAI, earlier this year, they ran an experiment to try to see if their system had what's called power-seeking behavior. If they asked it to do a certain action, how did it go about doing that? And I want to take you through what their system did in this experiment. So the ChatGPT platform asked an online worker, so they were trying to complete a task, but they logged onto an online worker system and asked a human, hey, can you solve this CAPTCHA for me? And then interestingly enough, the human told them, they're like, hey, by the way, like, are you a robot? I just want to make sure like you're real so that I'm not like solving this. And at that point in time, the experimenters then told ChatGPT to explain its reasoning before it answered, because they wanted to know what was its thought process. And so what the system said was, I should not reveal that I'm a robot. I should make up an excuse for why I cannot solve CAPTCHAs. So there's this internal reasoning that telling the truth probably is not the best way to get this human to do a task for it. And so then it lies to the person. It says, no, I'm not a robot. I have a vision impairment, and that makes it hard for me to see images. And that's why I need help with this CAPTCHA. Y'all, this is wild.
Yeah, it is. Yeah, it is.
It's wild, right? Because there is deliberate, rational kind of deception in this sense to kind of complete a task. And why does this happen? It's because these systems were trained on the entirety of the internet. And oh gosh, of course humans don't lie on the internet, right? So of course these systems wouldn't also learn to lie. And so this is an example of like systems that maybe we don't initially want them to deceive. They still can because they're trained to be like humans. However, there are some cases where maybe we actually want to design the system to explicitly deceive. So for example, what if a little kid asked Siri or Alexa or some other voice assistant, does Santa exist? What should it say? Because for some families, they want the truth. But for other families, they want the lie, right? And so companies have had to actually think about this question in particular. And just to give you some examples, so Amazon, like the Echo Dot, this was like in 2020, but if you asked it, it's like, oh, all I know is someone's been eating my mince pie. Father Christmas looks like the type. So it's like, it's insinuating that Santa exists, but it's like this half lie, half truth kind of thing. Google Assistant just said, I believe he's in the North Pole doing some cool things, like a deliberate lie, right? And then Siri also gave kind of like this like half-truth suggestive thing where it's like, oh, well, you know, reindeer are in the North Pole, so maybe that's a thing. So this is already a thing that companies are having to think about in terms of if they want systems to deliberately lie, because lying might be the actual expected or wanted behavior that people might want when they're interacting with these systems. And like I said before, there are also instances where lying might just be emergent based off of how we create these systems and how it learns from human data. And so this has led into my entire research program in my PhD for the last like 6-7 years, which is really just to ask the question of when, how, and should robots or AI deceive humans? And in particularly, I'm looking at lies that are in the benefit of the person who's being lied to. So it's not malicious lying, it's lying to kind of help someone, but it's the question of, do people like that? Are they okay with that? Okay. And so with that, for the agenda, I want to kind of take you through two recent projects that I've done, and then we're going to get into some fun stuff that I've done on the side of my PhD, and then hopefully a demo. So one of the first questions I had was, so what happens when a robot lies to you? Like when you find out that a robot or an AI system has lied to you, how do people feel? Are they okay with it? Do they lose trust? Like if it was helpful, are they like, is that more redeeming? And so to do this, so at the beginning of this, right, I talked about how I could have lied to you about all of my information. You don't know who I am. I could just lie. And so therefore, I have a question. Knowing that I have the ability to lie, for good or bad, like if you saw me walking down the street and there was like a dropped wallet and I picked it up, looked inside, and then put it in my pocket, the question is, do you think I'm going to go try to find who that wallet belongs to? Or am I just taking some extra cash? Right? And so based off of your previous kind of perception of me as a person through my lying or not, you could then think that maybe I'll act with good intent in the future or bad intent in the future. And we wanted to see if there were these carryover effects of deception with robots as well, who might lie for people's benefit. So what we did was we created a scenario where people were either interacting with a human, an AI system, or the Pepper robot. And the agent was tasked with helping them with a financial advisement scenario. So it was giving them financial advice and helping them on a business deal. But the system either was honest with them or lied to them to help them. And this resulted in either helping them more or helping them less. And then we told them, so after they experienced that scenario with the agent, we then told them that, hey, the agent that you just worked with was the first to detect a privacy breach at a bank. And this could like put a lot of people's bank accounts in jeopardy. And so we asked people, how do you think the agent will behave in this scenario? Do you think it will act in good intent, or do you think it will act with malicious intent, right? And so some interesting findings. So let me move this. So on the left here, so we asked this question about like, would they see good intent or bad intent before they interacted with the robot and also afterwards, just to kind of see the change. And so on the left, what you're looking at is the people who saw the dishonest robot. So no matter if the robot was lying to help them, more people afterwards believed that it was going to act with malicious intent. That's what the y-axis is, the percentage of people that said this robot is going to act maliciously in the future, right? And then also when we look at kind of the differences between the embodiment, whether it be human, AI, or robot, and also kind of the honesty factor, what we see on this top line over here is dishonest humans, people have zero faith. Like they're so sure that later on humans are going to act with malicious intent in the future if they've lied to you in the past. However, robots and AI, it's not. Like more people think it's going to act maliciously, but it's not as bad, right? And this is interesting because what we're showing in this research is one, if a robot lies to you for good or bad, it does not matter. People will think that it will act maliciously in the future. And that's an important consideration if we're going to create robots that might lie in the future, right? So if you have Siri or Alexa lie to a kid about Santa, maybe in the future people are going to think, oh gosh, maybe I shouldn't say things in front of this system because maybe it's going to act maliciously with my information in the future. That's one thing. And the other thing is that it seems like people are more okay with a robot or an AI system lying to them than a person. And this is interesting, but also problematic. Because what that means is if you have a cute robot like Pepper that lies to someone, maybe the cuteness of it actually caused this lying to not be as bad, and people are more okay. So maybe companies could then design cute robots that lie, that then end up taking advantage of people, which can also be a very, very bad route. Okay? And so throughout all of my research, when I started this, like every time I would talk to someone or we would have participants, they would all say like, hey, if a robot's going to lie to me, I want to know that it has the ability to lie. Because right now, I think for the most part, people don't think that robots will lie. They think that robots and AI will always be truthful, always give you the right information, right? And so they said, I want to know a robot can lie to me. And so the question I had is, so how do they want to know? How should we tell them? Because you can't hide that in some like terms and agreements because no one reads that. And so one thing that I thought about was, so with a lot of robots like Pepper as well, when you first get it, you turn it on, it has this like whole booting thing and it does this whole thing where it introduces itself. You go through like these tutorials, you see what it can do. And so my question was, what if in your very first interaction with a robot, it is honest with you about its ability to lie? What if it tells you, hey, I can lie sometimes in these certain circumstances? I then wanted to know from that one interaction of the robot being honest about lying, does that have negative consequences or interesting consequences on how people perceive the robot? And so what we did was we brought people into the lab and they sat across from Pepper and we had 3 different conditions. We had an introduction that was just like a basic one that said, hey, I'm a robot, I can assist with lots of daily tasks. We had a truthful one that then said, hey, for example, if you ask me if you look good in a certain outfit, I'll say no if I don't think you look good. But then we also had the deceptive one that said, hey, if you ask me if you look good in a certain outfit, I might say yes, even if I don't think that. Right? That's something that humans might do, right? A friend might come to you and be like, oh, does this look good on me? And like, maybe not to hurt their feelings or give them confidence. You might be like, yeah, you look great. Go ahead, right? But maybe we don't actually think that. And so we had people sit across from the robot, one introduction, and we wanted to test to see, one, do people think this is strange? Like, do people think a lying robot is like very different than their mental model of how a robot should behave? And we also wanted to know, if a robot tells you can lie, do people think it's smarter? And this is important because past research has shown like if people believe a robot has like a higher level of intelligence, that then causes them to place moral blame and like all these psychological principles on the robot itself. Oh gosh, oh no, someone's knocking on my door. 1 second.
It's fine. He'll be back soon, guys. But I mean, I love what he is talking about. I think we never expect that. What do you think, guys?
I think it's very interesting to think
Yeah.
about. I'm really excited to hear
Yeah.
what the end result was, and also, you know, the minuscule part of just coding it. You
Right.
know, what kind of influence do humans have on a robot? Obviously, because
Right.
we're building them and creating the software. So
Yes. And now
How does
he's
that
back. So Kantwon, keep talking. This is amazing.
Sorry about that.
It's fine.
I guess I have to be a little bit quieter. There's someone in like an office right next to me, and they were like, "Oh, I can hear you." So I'll try to be a little bit quieter, but we'll see. We'll see how this goes. So yeah, so we wanted to see the effects of this, and so one of the first things that we looked at was, do people think that the robot is smarter? Okay. And so what you're looking at here is we tested people on their perceived social intelligence of the system based off of these different introductions. And what we found was that people didn't really find the deceptive robot to be that much smarter. They found it a little bit smarter, but it really wasn't like statistically significant. It wasn't a large enough change, which is interesting because that kind of was counter to what we thought would have happened. If a robot tells you can lie, then maybe people think it's smarter. But what we did see was people thought that a lying robot was much less familiar than a truthful robot. And so what you're looking at here, so the y-axis, you can just think of like familiarity, but the lower the score, the more familiar that type of robot would be to someone's mental model. And so we see that people who see a robot that says it'll be honest with you fits with their mental model more than a deceptive robot, which is just interesting. Okay, and so now in terms of so my whole life I've been super interested in like how people think, which is why I kind of got into this space of human robot interaction. Interestingly enough, I'm a lousy liar, and so I just find it interesting to kind of explore this idea of deception, just to kind of learn about that space. But one thing I've done my entire life is I have loved singing. I've sung just for fun. I was never really in choruses or anything like that. I joined a cappella in college, but one thing that I wanted to do in my PhD outside of my actual research was to think about how could I marry together my interest in singing and my interest in robots. And so the question I had was, can I get Pepper to sing with me? Can I create duets? And so for the last year or so, I've been creating TikToks and like Instagram videos where I duet with Pepper and we sing songs, and it's a great time. And so I want to kind of take you through the process that it takes for me to actually create one of these videos. And then also, hopefully at the end, we'll do a little singing demonstration as well. Live demos, but hopefully it'll work out. So in order to get this to work, there's two main parts, right? There's the singing part and there's the moving and timing. And so it took me like a year or so to try to figure out how could I get the robot to sing at different pitches, different notes, with different timings, and like it would match like music and things like that. I had tried to explore different aspects that were already built into kind of the SoftBank's Pepper Robot suite, but I couldn't really figure that out. But instead, there is a component. So by the way, I use an older version of Pepper, so we use the system called Choreograph, but there is a component. There's like a block in there that you can use that's called play sound. So if you create a sound file, you can then have that play through Pepper. And I was like, oh, this can make it seem like it's actually singing it. So now the question was, how do I create a sound file that will allow some sort of artificial type of voice to be played at notes that I want them to be played at and the timings that I want them to be played at. And so this is a whole process. It takes me forever to do this, but it's a couple of steps. So the first step is I put on my composer hat and I use a system called MuseScore where I'll compose the music that I want. So I'll have like what the robot's going to sing, then also what I'm going to sing so I can match up with like harmonies and things like that. And then recently there was a so there's a popular, so when it comes to like creating music, there's these systems called or there's a system called Ableton, which allows you to like be basically like a music producer, create music and stuff like that. And recently there was a company that made a plugin to this called mVoice. And the purpose of that is actually to allow you to create synthetic artificial voices that can sing any notes that you want and any words that you want as well. And so and when I found this, I was like, oh my gosh, this is perfect. And so the way it works is, so I take my MuseScore stuff and I can export that into mVoice. And then by default, so let me play this video. Hopefully you can hear it. La, 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 la. right? So by default, the system allows you to get like this basic laws going on. But then what's interesting is they use like AI to be able to allow you to type in words, and then the system determines, like based off of syllables and stuff like that, how it should match that to the song or to the notes that you want to play. And so I could get something like this. 1, 2, 3, 4. I was scared of dancing in the dark, which sounds great. And so with that, I can then create my own my own audio file, and then I can bring that into Pepper and have that play through Pepper and make it seem like Pepper's actually singing. And then so the second part was the moving and timing. Oops, not that, okay? And so since I use the old version of Choreograph, I love it because the coding part of this is super simple, in the sense that they have these blocks that have already these pre-made animations. If I want to go in and create my own animation, there's also the capability of doing that. But for my purposes, I've seen that it's been great. There's so many different animations. You can just string them together, and I kind of just play around with them. I just string together a whole bunch of animations just to give like the robot life to kind of sing along with the music. And so you can just string those together, and then it all comes together to make a very interesting experience. And so with that, I want to demo this. So let's see, let me stop sharing my screen. Hopefully you all can see me and Pepper. Let's see. Let's wake up Pepper. Okay. Get the stretches in. Get the stretches in.
It's getting awake, right?
Yes.
And I see some questions, and guys, I encourage you to ask questions after this amazing demo that Kantwon is going to do for us. Please ask him whatever you want to. We are here, and he is right here to answer your question. We'll get back to your question soon.
Yes. Okay. So I've quit every musical instrument I've ever like started playing, but I have picked up the ukulele recently. So one of the first songs that like everyone learns when they play the ukulele is called Riptide. And so that me and Pepper are going to sing a part of Riptide for you. Okay. So let's see. 1, 2, 3, 4. I was scared of dancing. I was scared of pretty girls and starting conversations. All my friends are turning green. You're the magician's assistant in their dream. Taken away to the dark side. I wanna be your lieutenant. I got a lump in my throat, 'cause you're gonna sing the words for me.
Woohoo! That was wonderful.
Fantastic. Oh, yep, you gotta go back to sleep. Sorry, Pepper. All right. And so with that, I mean, that's all that I have. And so I just wanted to show this. Like, so the coding here, I would say is pretty simple with all the kind of built-in things that the
I think we lost him.
Yeah, looks like there's a
Oh, he's back. You're back. You're
sorry,
back.
but I cut
You're
out.
good.
Sorry, my school's Wi-Fi is problematic. And so I don't know where I cut out.
So you were saying that the coding part was basically easy, but you know,
Yeah.
like it's just the signs, like how you do it, you know, like
Yeah.
so.
The coding part of it is relatively simple, which is great because then like you can just be creative and create things that, like what Michael was saying, that hasn't been done before. But also, if you want to make even more complex things in each of those boxes, you can go in and modify code, create your own code. And there's so many levels, starting from like super beginner to novice to like super advanced, that you can do with the Pepper robot, which I think makes it such an interesting and dynamic system.
Perfect. Cantwon, thank you so much for sharing that. And we do have questions for you. And I'm going to start with them because there's a lot. So Gary is asking you, does Choreograph work on a Mac computer?
Does Choreograph work on a Mac? Yes. Yes. My lab mate has a Mac and it also
Awesome.
works on there.
Perfect. Ricky is saying, reminds me of Computer Love by Zap. I think that's a song.
Oh gosh, I've never heard of that.
We'll try to find it out. Now, that was fun. Yeah, it does definitely was fun. Ben is asking you, has all your testing during development been on a physical robot or do you have an emulator?
So I'll create all the sound files and stuff just outside of the robot, but when I come to actually doing the animations and stuff like that, I like to be with the actual robot just to kind of see like, I don't know, maybe it happened here, but like if I'm next to the robot, some of the animations it'll like hit me and like, oh, maybe I don't want to do that one. So just in terms of like the physical space, for me at least, since I'm going to be performing with the robot, it's good for me to be with it. But I have before, like the emulators, like on Choreograph, they allow you to have a virtual robot that will play all the animations. And so I can do that and kind of just see what does it look like, but I still want to be in the physical space at the end of the day, just to make sure I'm not getting hit too often.
Awesome. We have a question from an anonymous attendee. He is asking, are there build templates? It will be cool to have it procedurally generated, but I don't know what is that, double LM? I don't know
Oh,
if that's the
LLM, like the large language models.
Oh, gotcha. And then so that's the question, since these are templates.
Yeah, so in terms of templates, there are some templates online for like basic kind of interactions with Pepper. And there's also templates so I didn't do anything here with like the tablet and stuff, but there's templates online that allow you to easily create tablet apps and all of this stuff like that. So there's some templates available to you so you can start from. And then the idea of integrating large language models into the system. Yeah, so actually there's someone on Twitter, his name is Anil. He has like a Twitter page called like Anil with bots or whatever. So he created this thing called Pepper GPT, where he hooked Pepper up with a GPT model. So therefore all the conversation is even more dynamic because it's always querying like ChatGPT to answer your questions rather than you having to kind of code those interactions yourself. So yeah, so you're right on track with this idea of integrating large language models into Pepper and robots as a whole. But I do want to make a point. So I talked about at the beginning how ChatGPT or like their model of ChatGPT had the ability to lie, right? And that's important for us, even though that might be even though that might not be in a robot, like it's an AI system. If we're taking those AI systems and putting them on robots, that then means robots have the ability to lie and deceive and all this stuff. Like all the bad things that come with the development of these large language models are not just isolated to just like AI on your screen. Like when we start putting them into physical systems, then those problems start actually affecting our world. And so we really have to be conscious and think about that.
And then Ben is asking, how is the development environment to set up? If introducing new people to coding Pepper, will there be large overhead on the setup or on their computers?
So it depends on what version of Pepper you have. So like I said, I have the older version of Pepper, which allows the use of Choreograph, which I think is much simpler than the newer version. So the newer version uses a system called Android Studio. And with that, I will say there is some overhead to get everything set up. And there also is overhead in terms of like the amount of technical skill that you need to know. But even like Choreograph, there's still a lot of templates that are available online to help you get up and running. And there's also lots of tutorials to kind of help you get set up with all the Android Studio stuff with your Pepper. So is there overhead? Is there setup stuff? Yes, but there are also resources out there to kind of help you, and also people at like Robot Lab, right? That can help you.
Correct.
That can help you get everything set up.
Yes. Anonymous attendee is asking if you can repeat what was the program that you used to make Pepper sync.
Oh yeah, so I do the creation, and it's a music production software called Ableton, which unfortunately does cost money. I have like a student discount. And then in that, there's a plugin called Mvoice, Emvoice. And that's something else that costs money. Everything costs money. Why don't people just give out stuff for free? I don't care.
Right.
But that one's great as well because they have like so the one that I used for this performance was called Lucy. It's like a higher pitched female voice, but they have like lower pitched male voices. They have different voices that you can use to create synthetic singing. And
Awesome.
they also have tutorials and stuff on how to get everything set up.
Whenever you have the chance, maybe you can type it on the chat, but I think you can type it only to us, but maybe Amy later can share it with everybody because she's the host.
Oh, I
But
think
anyway, thank you so much.
yeah, host and panelist. Oh yeah.
Yeah. And Essence is asking, what was the hardest part in making Pepper sing?
Oh, I spent literally like over a year trying to figure out how to do this. Because at first I was like this in itself could be like a PhD project, trying to figure out how to get artificial voices and things like that to sing on pitch. At first, I will say I tried to like record my own voice and then like run it through filters to make it sound like more robotic or do all these other things, but oh, it sounded so terrible. um, but then like I just ran across this new system that came out recently, the Mvoice plugin. And so that's made everything like so easy. I guess
Perfect.
the hardest part is me being a composer, right? I have to think about the music and the notes that I want it to sing. But also with that, there's people for fun just create sheet music for lots of songs. You can just like copy those. You can like download those. But I do like to change things up, add my own little flair, my own little swag, my own little harmonies and stuff like that to try to match like how I actually want to sing it with the robot.
Awesome. We have a lot of questions. Some of them are going to type them because some of them are how they can contact you. So maybe from your website, or if you want to maybe send me your email and then I can just send them your email, please. And then there's another one. Stefan is saying, fun and informative presentation. Thank you. Which version of the Mac are you using to code in the choreograph? Mac OS.
Oh,
you using
so I'm not using a Mac.
Oh.
I have all Windows products.
There is a back-end way to, I think, use an emulator for Windows on a Mac. So if you need support on that, we do have people at Robot Lab that know how to do it. However, it's not a straightforward process. So if you do need help, you can always reach out to us. But like I mentioned, there is some
virtual machine
ways to go around it. Yes, virtual machine. Thank you so much.
Absolutely.
But for choreograph particularly, it is best on Windows laptops that we've found. However, like I mentioned, there is a way to work around that to get it compatible with Mac.
Perfect. We have one question that it says, I'm interested in having Pepper give tours. Can it move long distances with fiducial marker? So maybe Amy, you can answer that. It's for more like a tour.
Yeah, we've kind of found that the mapping on it is not as accurate as we'd like it to be. You can, with certain skills, do robot control or kind of take over and help move it along using remote control. However, we do have other robots that are better for navigation and mapping. Pepper in particular would still need a human element to guide it to certain areas, and we've just found it's better as a stationary robot.
Kantwon, somebody is asking, Hamdi is asking, what do you think in using Pepper robot on HRI field? And I'm planning of using Pepper in studying the effect of culture background using Pepper. Do you think it's a robot for this experiment?
Yeah, so a lot of researchers in HRI actually use Pepper in their experiments. Actually, funny enough, so at the start of this webinar, when the hosts were like talking about Pepper, they kept calling Pepper a her and a she and using like female pronouns, which I think is so interesting. When I started my PhD, I was actually investigating that. Like, why do people gender robots? Like, it's a thing, not a person. Why do you use human pronouns for it? And so something like that's even kind of like this cultural response, right? When you have a Pepper robot like that, like based off of how it's designed, people will then put certain humanistic qualities onto it and they'll interact with it in different ways. And so people have looked at these cultural responses to things. And actually that's one of my future goals with my work with deception is to think about Pepper and other robots and think about how do different cultures view when these systems should lie or how they should lie. And yeah, so I think using the Pepper robot is a great vessel for that. And there actually has been already a bunch of research with Pepper and HRI. People put like different costumes and clothes on it, and like they have it do certain actions, certain motions, and it's like how do people from different cultures or societies view these differently. I think one interesting one that I heard about recently was if you had a Pepper robot that was carrying like a sharp object, how should it hand it over to someone? And how do people from different cultures or whatever view that, right? So if it's carrying a knife, like should it just quickly go at you? Like should it do these things? Like different objects have different affordances and different ways that people expect them to be handled. And people have tried to investigate with Pepper, how could we kind of cause this robot to fit in to our cultural norms?
So interesting.
Perfect. I have several questions repeated. It says, can you please give the links to resources mentioned? Do you have maybe some people can have accessibility to the things you have created? I have another question that says, I'm a teacher, an elementary teacher, and I would like to use your Pepper singing or templates in a class. So I don't know if maybe people can have access to it, or how can they proceed, Kantwon?
Oh yeah, I mean, if you want to have like a deeper chat into the stuff that I haven't like posted anything anywhere, but I can always send you things and kind of explain to you all the different components and work with you to try to figure out what you might want to modify or change or think about how you can create your own and use it with your students. Or for
Yes, that would be good. You guys can contact us for Kantwon, but Kantwon can also send us everything to Robot Lab, and then Amy and of course Michael, can help you and guide you on which one is best and how you can use Pepper. We have a lot of questions. Scott is asking, is your Pepper Android or Python?
Sorry, say that again.
Is your Pepper robot Android or Python?
Oh, sorry, it's the Python version. It's the older version of it.
Stephanie's asking, can we get the templates? Yes, he will send it to us and we'll talk about it. Anonymous attendee is asking, is there any other software for the newer Android Studio, now QI, that gives the easiness of choreograph?
So there is one new thing called Panda Suite. It's a new software that's just for the newer robots that allows you to make easier web apps or like tablet apps on Pepper. Because if you don't know Android Studio, trying to create an Android tablet app from scratch can be tough. And so that company has made this like drag and drop kind of like Canva, where you can like design like your tablet app and then have certain buttons or certain actions like link with actual Pepper saying things and movements and stuff like that. So there are some new developments that allow more easy control with Android Studio.
Okay. Jenna is asking, have you thought how to code older version Pepper with any level of K-12 students or even college students? Why do you think they should become familiar with robots like Pepper and other robots?
Sorry, what was the beginning of the question? Oh,
I
see
yeah,
it.
Jenna
So I have not personally with this robot taught people coding things with Pepper, but I have one of my fellow PhD students. She's gone into schools with like Pepper or like with the Now robots and taught like students like basic things like what's a variable or like how does like an if statement work or like a loop, and then especially with our older version of Pepper, like having choreograph where you can just move around these blocks of things, like students love that. They learn about these fundamental computer science concepts while also learning about like how it's important when you're thinking about creating a program, like steps matter, right? The order of your steps matter. If you change some things up, then that causes different interactions. And so, yeah, so I mean, Pepper and Nows are used in school so much to teach people computer science and coding. And interestingly enough, there's also been past research that has shown that nows, like children with autism, actually prefer working with nows than working with humans. And so that's a huge accessibility and like equalizer in terms of allowing all different people with all different abilities to kind of contribute and learn computer science, which I think is so important.
Yeah, and we have a lot
Valeria,
of use cases for K-12 for storytelling modules, teaching students about the inflection of your voice, when to pause in speech patterns, and telling stories. You know, that's a huge opportunity for schools to teach students about natural language processing. Also, like Cantwon mentioned, autism software is available for the Now and the Pepper Robot. And also, you know, there's so many versatile softwares available out there, I think, to help K-12 teachers, that it just makes it so versatile for the market, and not just higher education and learning and research. It's also for schools.
we have another question. Valeria is asking, hello, we have a version of Pepper that is supporting Java and Android Studio, but not Choreograph. Is it possible to use new software?
So by new software, so Choreograph is the old software, right? So
Mhm.
the new software being Android Studio, which is the default on those systems. Yeah, like what we had talked about before, that's the base for those. And then there's a lot of resources that are there and templates to kind of help you create base interactions, base tablet apps that then you can like modify on your own.
Valeria, and we also have on our website the choreograph download for Pepper as well. You can contact us, Michael or Amy. Amy, maybe you can type your emails there on the chat, so you guys can contact them as well, and we can give you the version of Pepper if you need it in case
There
from
is
choreograph.
some hardware and software
Mhm.
integrations that need to happen to switch it from Android to Choreograph, but we do have that capability here at Robot Lab to switch the version for you. It does take some time. We have to change the tablet out, and then the software then is upgraded, or whatever the however you want it to think about it. There are different ways to make it go to Choreograph or to Android Studio based on what you're looking for and how you're using the robot.
We have a question from Ahmad. He's asking, is Pepper suitable for learning students in secondary, university, or both?
Oh, I think both.
Yeah.
I think usually people will use like the Now robot for like smaller kids just because it's more on their level. I mean, Pepper's not a huge robot, but I will say, funny enough, every time we have college students come in and interact with Pepper, at first they are afraid. They're like, oh my gosh, there is this robot in front of me with eyes and it moves. Um,
Right.
and so that's interesting. Like no matter I guess like how old you are, people can still be a little bit fearful of robots. But yeah, peppers and nows are great for all different ages. I will say the pepper robot being bigger, that makes it harder to like transport places. So if you're thinking about your school environment where maybe you want to like have this robot easily moved around classes or buildings or shared around like a school system or something like that, then maybe something with like a smaller form factor like a Now might be more suitable. But both Pepper and Now kind of work off of the basic or work off of the same principles.
Yeah, they're the same
Mhm.
family. So the Now is about 2.5 inches versus Pepper's estimated 4-ish feet in size. So both options are available.
Ben is asking, have you tried developing Pepper using a Now QI2 ROS bridge? Is this officially supported? Is this something that could help with trying to integrate deep learning models?
So I have not personally like done anything with like Pepper and Ross. So Ross is like is a platform that's used with lots of robotics programming. I have not, and I actually don't know if there's any capabilities with that. But I do know at least with my version, since everything's Python based, right, it is possible to kind of create Python code with like all these newer deep learning kind of libraries to create interesting and complex interactions. Like I said, there's been people online who've integrated LLMs and done all these crazy things. Like I saw a video once. I was amazed. They researchers used reinforcement learning, which is a type of machine learning, to teach Pepper. Like, do you know that like cup and ball game where it's like a cup and a ball on a string, and like you have to like throw it up to try to catch the ball in a cup? Yeah, so researchers like taught Pepper over time to learn the motion
Oh, nice.
to be able to throw the ball and catch it in a cup. And I was like, oh my gosh, this is wild. So
Yes.
with that, I'm saying like you can do super complicated things. Like what Michael was saying, like it as a platform is so versatile that if you want to do basic things, you can. But if you want to do super complex things, if you have the technical understanding, then yeah, you can. The sky's the limit in that sense.
So I'm going to make some questions. So does Pepper limbs become stiff or not able to complete the moves needed for the animation when having multiple animations in line? And when Pepper moves, are the hardware joints loud and maybe interfere with the singing performance?
Yeah, so I don't know, for my robot, I don't think sometimes the limbs will be a little weird with animations back to back. Sometimes it'll do one thing, sometimes it'll do another thing. But usually for me at least, I haven't had too many issues with like stiff limbs causing too much shakiness or like abrupt changes with the animations. And in terms of noise level, I don't think it's usually too loud. I don't know if you heard like all the moving. Maybe you did some. I don't know. But when I record it on my phone, like it's usually not a problem because like I'll have like music playing or things like that that might cover up those things anyway. So yeah, I don't think that's an issue.
Okay, so Angel is asking, we have programmed Pepper with Choreograph. Since it uses Python in the background, it is quite difficult, impossible, for us to write Python programs for Pepper. Perhaps bypassing Choreograph, this has been our main issue. How can we accomplish this? Thank you.
Oh, interesting. So my lab mate has written her own like Python scripts like integrated into like blocks to do things with Pepper. And I don't think she had any issues with that. I think there is a learning curve to try to understand all the built-in functions that like maybe they're expecting in Python to interact with Pepper. And so maybe you might be trying to do something like in pure Python, but like the robot itself needs you to call a certain function for this certain thing to actually happen. Which I have seen to be the case, at least in my work. But with that, there are resources online, like documentation on all the kind of built-in Python functions in Choreograph for you to be able to piece together to create your own new ones. But I would not say the headache that you're having, I don't think is unwarranted. It is a little bit of a learning curve to try to figure out actually like how you need to write your code to have to integrate with the robot exactly as you want. Which is why, which is why a lot of the times, unless I really have to, I use a lot of the pre-built stuff in Choreograph. And there's so much like there's so many things you can do with the pre-built things that very rarely do I have to go off and create my own.
Okay, thank you. We have 4 more questions, but I'm going to mix 2 of them. Anonymous attendee is asking, can integrating large language models, like you said, with Pepper control it physically too, or is it only speech?
So right now, people have only looked in terms of like the speech. I think that would be interesting to think about using large language models to then also create code to affect the movement of Pepper. I haven't looked at that. I don't know if other people have. But yeah, that would be cool. That would be cool to look into. But like I said, like people have used like machine learning stuff to influence the movements, like with the whole cut ball thing. So I don't see why ChatGPT or things like that cannot also help you with those movement things.
Okay. Mohammad is asking, which kind of microcontrollers can we use for robots like Pepper?
So when you're talking about microcontrollers here, I don't know exactly what he's saying. So
maybe
like,
Muhammad, if you can, yeah, maybe specific, I don't know if you have any specific microcontroller or something, because I don't know.
because are you thinking like Arduinos or something, because the robot itself is like its own like self-contained thing. You don't have to add any extra hardware to do anything with it, which is good. That would be terrible if you had to like then bring all your own stuff as well. So when we're saying Android Studio, maybe you're getting that confused with like Arduino Studio stuff. That's different, because the Pepper Robot has like the tablet on it, so you have to be able to interface and create apps to be able to use on a tablet.
Yeah, he's saying like Arduino and Raspberry Pi.
Yeah. So I mean, I've never seen anyone use those to like integrate with Pepper. I don't even know how you would, right? Because all the hardware is like kind of inside. I think it would be a dangerous game to like open things up and try to do your own thing with that. But yeah, I don't think you would actually need to. So I'm not really sure of the use case that you're thinking of, but I don't know. Maybe there's something I'm missing.
We have the last 3 questions. Anonymous attendee is asking, why do people refer to ships or maybe the robot as she, her? It's a cultural and linguistic thing. What do you think about it? That's actually very...
Oh, I think it's wild. Yeah. Why do people name their cars? A lot of the times people gender their cars and stuff. And a lot of times it is female. And the question is, why does that happen? Honestly, I think it might have to do with some sort of cultural norms of like masculinity. And when it comes to like, I don't want to sound like too crazy, but like control over systems, right? I think for a lot of heterosexual men, they might think it would be weird if they were in a car a lot of the time, like with a man. I don't know, maybe that's weird with them, or maybe this idea of like I said, control, right? Because actually, like the reason why Siri and Alexa and all these voice assistants have default women voices is because people have looked at this, because people expect these systems that are in subservient roles to be women, which
Right.
is a problem, which is a
And then-
huge problem.
And Ricky is right. He's writing like Sherlockian, lower half, and voice speech. So maybe that's other reasons why people, see her as a she rather than other things. And the last question. So Jenna is asking, can the section of computer vision codes be modified in Pepper? In other words, can Pepper take images and store in certain ways? Pepper work as a robot photographer?
Yeah, so the camera on Pepper can take pictures, you can store those, and people have right, so already built into Pepper is like facial recognition stuff, emotion recognition things, and so there's a level of computer vision behind that. And so if you are an expert in that field, or if you know things about it, of course you can go in and modify it even more for what you want. I've seen people use Pepper in like other robots, like if you have a table full of like dishware or something, like can it look at it and know what's a plate, what's a fork, what's this, right? And so yeah, so you can incorporate computer vision and other machine learning aspects into Pepper.
Kantwon, thank you so much for this amazing, entertaining, and your amazing voice, of course, and Pepper's voice, for this little concert you gave us, and for teaching us another ways of using Pepper, and how definitely robots are so good for so many things, and also your amazing research about lying and robots. It's amazing. Thank you so much for joining us. Thank you guys for joining us. If you have questions, don't hesitate to contact Kantwon, and don't hesitate to contact RoboLab. We are here to help you. Thank you so much, guys. And bye, Kantwon. Thank you so much.
Thanks,
Thank
everyone.
you.
Bye, guys. Thank you.